Hey guys, we're going to do the 8.1 lesson check. So let's get started. It says use the Pythagorean theorem to solve for x. Okay, so we're going to order the sides least to greatest. We'll call that A, B, and C, right? So it looks like A is 9 and B is 12. And C, we don't know. That's what I guess they're calling x. So we take the square root and we get 15 and we plug this back in to see if it makes sense. So does that make sense that the small side's 9, medium is 12, and the longest side is 15? And the answer would be yes, that does make sense. Okay, our next question, you're saying, oh, that's a special triangle, right? Because it was an equilateral triangle cut in half. So we can look back in our notes and we notice that it was an equilateral triangle. And so when you drop this altitude, notice this got cut in half. So that would be 4, right? And then we can use Pythagorean theorem here if we want to solve for this missing side. We'll call this A, and we can call this B and call that C. So A is 4. B they're calling x, okay. And C is 8. Okay, so x is equal to the square root of 48, but that's none of our choices. So you're saying, couple ways to figure out which one is our answer. So it's square root of 48 is the decimal, 6.9, and figure out what these are as a decimal. So 8 times the square root of 3, you take the square root of 3 and then multiply by 8. We get a number even bigger, 13.9, and then when we do 4, the square root of 3 times 4, 1.7 times 4 is a little bit bigger, 6.9. Okay, so this is definitely our answer. How else could we got it? Well, we notice our pattern, right? That this is that same number times the square root of 3. We also could have reduced this. And so I could rewrite this. This is 4 times 12. And 12 has another 4. 12 is 4 times 3. And so we see here that we also could have gotten that answer. A couple different ways to get that answer. All right, looking at number 3. There was an example like this in our notes. So I think the first one we saw in our notes today when this side was 5 times the square root of 2, and this was a square cut in half, right? This is 45, 45, 90. This would also be 5 times the square root of 2. And what would be our hypotenuse? And we noticed here this was 10. So using that same pattern, this would then be this, and this would then be 4. How else could you have done it? Again, you could use Pythagorean theorem and solve for the hypotenuse. So the first side is 2 times the square root of 2. And this other side had to be the same thing because it's the square cut in half. And our hypotenuse, they're calling A. So we'll call that A. Now, careful here. You do have to distribute this square sign. So you have to square this and also square that. Square this and also square that. So if we look at this here, that'd be 4 and just the plain old 2. This would also be 4 times 2. So we get 8 plus 8, which is 16. And the square root of 16 is, you guessed it, 4. So that would have been another way to solve for A. All right, using that same pattern here, right? If that's 6, this is 3 times the square root of 2, and this is 3 times the square root of 2, because 3 times the square root of 2 squared plus 3 times the square root of 2 squared has to equal 6 squared. That'd be 3 squared and 2. 3 squared and 2. 18 plus 18 is equal to 36. So we get 3 times the square root of 2. All right, last one. This is our equilateral triangle cut in half. How do I know? Well, that has to be 60 because that's 30, and that's 90. So this equilateral triangle looks like was not an integer because its altitude is an integer. So kind of working backwards or using our formulas, we find our small side, medium, and largest side. The small side, we normally in our formula call x. Our medium side is x times the square root of 3, and our longest side is 2x. Using that generic formula, we know that the medium side is 12. So we can use this to solve for x. Now the math gods get angry because we can't leave that square root of 3 on the denominator. So we have to rewrite it like that. And that was similar to what we had in our notes. So again, how did we have one like this? The one like this is this one right here, question number 5. This was 28. This small side is 28 times the square root of 3 divided by 3. And then this is just doubled. So let's look back on our notes. That's exactly what we got here. We have this is 12. So this is 12 times the square root of 3 over 3. This one, though, will simplify a little bit cleaner. So we get the small side is 4 times the square root of 3, which would mean if we multiply it by 2, the longer side would be 8 times the square root of 3. Which one do they want? They want this hypotenuse, so I get 8 times the square root of 3. Nice job, guys. See you next time.